Okay, so let's head back to our 2D perspective, and we're going to create a script for our player's behavior. So first we'll go back to our assets folder, right click and create a new folder and call this one scripts. We'll keep this nice and organized. In there, right click, create a new C# script, and we want to call this something appropriate, so I'm going to call mine scr_player behavior. And I just want to take this opportunity to remind people, don't put spaces in when naming your scripts, and also if you happen to create a new script and accidentally click off it and don't rename it, and you right click and rename it whatever, this will cause issues, because if you look in the script preview here, the name of the script and the name of the class need to be the same. So here the class is called new behavior script and the script is called C, whatever that it says, and they need to be exactly the same as with the first one. So if you mess up, just delete that and create a new one and name it properly the first time. Double click that and open it up in MonoDevelop or Visual Studio. Okay, so here is my player script. Empty as normal when you create a new one. First things first, we want to create some variables. So there's two that we want to create initially, and this is the first one is a private, and then it's going to be a reference to a transform, and I'm going to call it player transform. And the second variable we want to create is public floats, and this is going to be our speed. Now, this top one, so similar to the clicker game where we created a reference to a text element and then we had to sort of drag it in Unity. This is similar, however, we're going to put the transform into this variable a different way. So in void start, we are going to take that variable. So a transform is when we head back to Unity and click on our player object, our ship, we can see it has this transform component, and a transform just sort of keeps track of the position, the rotation and the scale of an object. And because we want to manipulate its position, we need a reference to the object's transform component. So that's what this is. I've created a reference to a transform component and called the reference player transform. And inside that reference, I want to put a transform component of the player object in the scene view. We can do this by using player transform equals get component with a less than and a greater than symbol, and we just type in here transform, and then you follow that with an open close brackets and a semicolon. So what this line of code does, or what get component does rather, is it will look at the object that this script is attached to and get its transform component, and then apply. And in this case, we are setting the player transform to that transform component. So instead of, I mean, we could have just gone, if I comment that out for a second and change this to a public variable, save that across, and we go to Unity. If I attach the player script to my player object, you can see I've got the player transform, which is empty, and the speed, which is set to 0. If I wanted to, I could just drag the ship into itself so it knows to reference itself as an object and retrieve its own transform component. That would work just fine. However, when doing it this way and making it a private variable and using the player transform equals get component transform, it's sort of doing that for me. I don't have to drag it in. It's just going to automatically look at the script, the object this script is attached to, and get its transform component and put it into that variable for me. So if now I've saved it and head back into Unity, I won't have the player transform, but I shouldn't need to worry about it. It's just going to do it for me automatically. Next up, we're going to be looking at player input. So we've kind of done this briefly previously, but what we want to do in this instance is detect whether the player is hitting one of the keyboard keys, and we want to use that information to manipulate the X position of the player sprite. So what I want to do is get my well, rather than use speed yet, we want to just create a variable within void update. So in this case, float move h. So this is going to be our horizontal movement, and I'm going to make that equal to input dot get axis, and open bracket, quotation mark, and then in here we type the word in horizontal, and then end with a semicolon and save that. What we've done here with this horizontal thing, if I just go into Unity for a second and open up edit and project settings, you get this window. And one of these sections on the left is input, and it gives you this drop down for axes. If I drop that down, we get a bunch of sort of references that Unity sort of has preloaded within it that allows us to map keyboard controls to certain keywords. So in our case, horizontal references the left and right keyboard keys. Other examples are fire 1, which is left control, but also it's the mouse left click, or things like jump, which is space. It's reference to space. So if I were to type in jump into here, then it would get that input from the player on the spacebar. But horizontal, if you look at this as well in the horizontal section, it says, okay, so the negative button is left and the positive button is right. So what this means is that when I press the left button on the keyboard, this will return a value of -1. If I press right on the keyboard, it will return a value of 1. If I'm not pressing them, it will return a value of 0. If I press them both together, then they should, in theory, cancel each other out and return a value of 0. So in this case, I've created a float called move h, which will either be -1, 0, or +1, depending on which keyboard keys, left or right, the player is pressing. And what we want to do with that information is, if we go back into Unity again just to demonstrate, the X position of the cube, the sprite, the turret, if it sort of starts there, if I want it to move left, I essentially want to subtract from the player's position to make it move in that direction. I want to subtract from its X value. If I wanted it to move right, I want to add to that X value, so I want to make it move that way. And so if, say, I start at 0, if I apply that value of -1 when I'm pressing left to the X value here, then or if I'm adding -1 to it, it will make it move to the left. Similarly, if I press right, it will start to add 1, and so it will cause it to move to the right, which is how we create this sort of illusion of movement in our 2D games. However, I cannot simply add on move h to the X value, because the X value is part of what is referred to as a vector 3. So a vector 3 is essentially another data type, similar to an integer or a float. However, a vector 3, or any vector, you also get vector 2s, they just contain a set of numbers. So traditionally, they are a set of numbers that are used to define direction and speed in one go, or they can be used to draw a line between 2 points. But for our purposes, we essentially just use vectors for collections of numbers that are related. So in this case, the transform dot position is a vector 3 because it contains an x, a y and a z. So it's just a set of 3 numbers together. And because of this, you can't simply add a number to a vector 3 because it's a set of 3 different numbers. So it wouldn't understand. Are you wanting to add this number to all 3 values? In which case, or do you want it to add it to just 1? It can't understand that. And so we've got to approach this from a different way. All we can do with a vector 3 is add another vector 3, so add a set of another 3 numbers, or we can multiply it to sort of scale it. So there's a couple of ways that we can apply another vector 3 value, or use vector 3s in order to add to this x value. So one way we could do this is we can create a new vector 3 that we can then apply to the existing vector 3, which is the player transform dot position. So we create a vector 3. It's another data type, so it's the same as creating a variable. So you say the data type, and then you say what you want to call it. So I might just call this movement. I'm going to say this equals, and then the way you type it out is you say new vector 3 open bracket. So again, a vector 3 is a set of 3 numbers, so I could type that out like that and it would be perfectly fine. In our case, we've got x, y and z. Y and z I don't want to touch, so I don't want to add anything or do anything to their values. However, the x value, I want to add on the value of move h, so that it adds or subtracts a 1 to the x location of our object. So instead of typing 0 here, if I type in move h. And so now I have a new vector 3 which has the move h value, which will update depending on what is pressed. And then now I can take the player transform dot position, because it's specified position because transform contains rotation and scale as well, and I can add on that new value of movement, and it should be happy with that. So essentially we create a float which is keyboard input, so it'll be either a -1, a 0 or a 1. We've got our vector 3 that we have created, because we can't just add one number to a set of 3 numbers, so we have to create a set of 3 numbers to add to a set of 3 numbers. So we've created this set of 3 numbers which we've called movement, and in that set of 3 numbers it's using that value from the player's input as the first one, which will be what we add on to the x value. Then we've said player transform dot position plus equals movement. So it's adding on our new set of 3 numbers, our vector 3 here, with the player input value given to us here, and adding it onto the current position of the player object, whatever their transform says. So if I hit save there and go back into Unity, we can see, if I hit play, make sure you've got your script attached to your object, but pressing left makes it move left, and pressing right makes it move right. And you can see its X position being manipulated up there in the transform component window. It's moving all very fast though, probably a bit too fast. And this is where we can use our speed variable. So currently our speed will be set to 0 at the start of the game, but what if I multiply this value? So we can't add to a single number to a vector 3, but we can multiply it. Essentially we'll just multiply every value within that vector 3 by whatever we say, and in this case multiply that by our speed. So if I come out of play mode here and hit play, again, once I've done that and try and move, it's not going to work. And this is because our speed value is by default set to 0, and so it's multiplying everything by 0 and not adding on anything to the position. If I change this to something like 0.5 and click back here, that will allow me to move. Again, it's probably still a little bit fast, so let's try something like, I don't know, 0.15. Will that be too slow? I don't know. That's not too bad. Probably could be a little bit faster, but I'm probably just going to leave it like that for now. So mess around with the speed value and make sure it's something that you're happy with. Remember, if you come out of play mode, it will revert back to 0. So just update that with the value that you're happy with. Just a heads up that the code that I've just shown you is different from what is shown in the PowerPoint. So if you're using both to follow along with how to make this, they will be different. The reason I've done that is because as I was typing this out and trying to explain it, it felt like this was easier to explain what a vector 3 was and how we were creating one and adding it, rather than what the script in the PowerPoint does, which essentially does this in less lines of code, or one line less. So if I just comment out those two so it will ignore them, what it does instead is it just takes the player transform value and adds on a sort of vector 3 shorthand in Unity. If you type in vector3.write, it basically essentially means it's a vector 3 of 1, 0, 0. And what we do is we multiply this by move h, and then multiply that again by speed. So it does the same thing that we want. Player transform dot position, pardon me. So player transform dot position plus equals vector3.write, which is 1, 0, 0, multiplies that by move h, which gives us our it's either -1, 1, or a 0, and then multiplies that by speed. So this line of code does the exact same thing as these two together. However, I just wanted to do this in order to demonstrate vector 3 is a bit better. Hopefully that hasn't confused things too much. That's it for this session. Next we'll look at creating a bullet object.